Okay, so I know you guys are going to be really excited about this, but did you know that you guys are used to seeing a complex number written in standard form, which is a plus bi? Okay, so this is what you're used to seeing. Now, this is not the only way to see this, okay? You can also see this in trig or polar form. And so here's what's going on. Okay, so let's say that the point a plus bi is right here. Okay, so let's just write a plus bi. And so if we draw that triangle in there, we've got this right here, which we'll call r. Last time we called it c, right? And we've got the triangle where this is length a and this is length b. Okay, and then I want you to notice that there's an angle right here formed when we make that line from the point to the origin, and that angle we'll call theta. Not a surprise, right? So remember, this is the real axis, this is the imaginary axis. Okay, so here's how polar form goes. Okay, I'll just write it up here first. So polar form looks like this. It's r, and then it's times the cosine of the angle plus I sine of the angle. Okay, so let's talk about where that comes from. So we all already know that r can be found by taking the square root of a squared plus b squared. Okay. I am going to backtrack a little bit. That was kind of dumb of me there. Okay. So let's just look at what r gives us here. Okay, remember how when we look at our triangle here, we can look at this as being theta, right? Even though this is really theta. We use this because this is the angle in the triangle that we're using to find sine and cosine. And so we have r times, now cosine of that angle is the adjacent over the radius, or the hypotenuse, sorry, plus, and then we have I, and then we have sine. Sine is the opposite over the hypotenuse. And so if we look at taking r times both of those, we have r times, oops, not what I wanted to do. We have r times a over r plus I r times b over r. And then if we look at each one separately, the r's cancel, so we have just a, and the r's cancel here, so we have bi. And that would then match up to the standard form. Okay, so that's how that works. Now we have a little bit of vocabulary that we need to do. And so the vocabulary is just kind of what we call each part. And so you might be asked to find these parts. Okay, so when we're looking at these, r is called the modulus. So r is called the modulus, just in case someone asks you to find the modulus. Theta is the argument, called the argument. Okay, r is the modulus, theta is the argument. Okay, now a is considered to be r times the cosine of theta. So let's look at that. A equals r times the cosine of theta. So if you think about it, cosine of theta equals adjacent over the hypotenuse. And if I multiply both sides by r, we'll see, oh, didn't mean to cancel that. Oh, okay, we'll see that these r's cancel out. So a is the r cosine, and likewise b is the r sine theta. Okay, and so if we take a plus bi, so this is just looking at another way, we can replace a with r cosine theta, and we can replace b with r sine theta. And then we have an I, and then we just take out the r from both of them and distribute it, and we'll see that we get up to this. So just another reason for that. Now, the whole purpose of what we're going to be doing is we are going to be taking something that is in standard form, a plus bi, and we're going to be putting it in modulus form. I lied. I'm trying to do too many things at once. So we're not putting modulus form, we're putting in trig or polar form. Okay, so let's try it. Okay, so here we're given -2 minus 2 root 3 I, and we're supposed to put that in trig form. Okay, so if we draw the picture of what's going on here, I've got -2 and then minus 2 root 3, whatever that is. That's going to be down here though, right? Okay, so if I draw in my triangle, I know this is -2 root 3. I know this is -2. So then I'm going to do the Pythagorean theorem to find the hypotenuse. So we've got -2 squared plus -2 root 3 squared. I'm going to square root that. Okay, so -2 squared is 4 plus, if I look at this, it's being multiplied, so I can distribute the squared. So -2 squared is 4 times, and then the square root of 3 squared, the square root and squared cancel, so I get 3, so 4 times 3 is 12. That gives me a square root of 16, which is 4. So I know now r is 4. Remember, my new form is going to be r times the cosine theta plus I sine theta. So our job is to figure out what is r and what is theta, and then we're done. So now I know that r is 4, so I put a 4 there. And now I just got to figure out what is theta, and I'm done. Okay, so now we got to figure out theta. We got to figure out this guy right here. Now you notice I'm given the opposite and I'm given the adjacent. Isn't that tangent? So tangent is the opposite, which would be -2 root 3, over the adjacent -2. Okay, so tangent of theta equals that. The negatives cancel, the -2's cancel. So now I have that tangent of theta equals the square root of 3. All right, square root of 3. Let's see here. I know I'm in the third quadrant, right? I'm trying to find this, and I'm trying to figure out when does tangent give me square root of 3. Now, if I take this one, where x is short, y is long, so that's the pi over 3 one. If I take that and take the y value divided by the x value, 2's cancel, I get the square root of 3, don't I? And I already know I'm in that quadrant because that's where I was told to draw it because of what I was told when it was in regular standard form. And so that is a version of pi over 3. And let's see, I'm after the pi, so it's bigger than 1 pi. So what is that? 4 pi over 3. So theta is 4 pi over 3. So that means I get to write down 4 pi over 3. And that's my answer. Once I know r and once I know theta, I just plug it in to the form and I get my answer. Okay, so let's try another one. So once again, I want to be able to replace the r and replace the theta. So why don't we, instead of putting an r there, I'll just leave that blank. I need to put something there. Okay, so let's look at the graph. We have 6 and then 2. So there's my point. Okay, I'm in the first quadrant. I've got a 2 and a 6, so now I need to find the hypotenuse, do the Pythagorean theorem. It's a square root of 2 squared is 4, 6 squared is 36. This is the square root of 40. I need to reduce that a little bit, right? So we've got 4 times 10, so that's 2 square roots of 10. So that is the r value. It's beautiful, isn't it? Then I want to find theta. And so we use tangent for that. So we know tangent of theta equals opposite over adjacent. So tangent of theta equals 1 over 3. Now, here's the thing. I don't know tangent of theta 1 over 3. None of our unit circle is going to figure that out for us. So I'm going to first go to my calculator. I'm going to make sure it's in degrees. And so then I'm going to go tangent inverse of 1 over 3. And it tells me it's 18.43. So I'm going to write 18.43 degrees and 18.43 degrees. Make sure to put degree symbol on there. And that's that one. So if it's not a unit circle number, like this was not a unit circle number, then it's okay to use your calculator and put it into degrees. Otherwise, you should definitely figure it out from the unit circle and use radians. Okay, now the other thing is we were lucky we were in the first quadrant. If this was in the third quadrant, then I would have to take my answer from the calculator and I'd have to translate it so that it is in the third quadrant. Because remember, your calculator, when you do an inverse, your calculator is going to have that restricted domain, so you won't be able to just use that answer. So make sure you're thinking about the answer the calculator gives you. All right, that is writing it from standard form to polar form. Good luck.